hey there guys, welcome back to my channel. And I am extremely sorry that there has been a lot of time since I updated my class 11th mathematics playlist. Okay, class 11th mathematics playlist. As you know, that I was going through a hectic schedule and I have to give the online and offline classes both. But I will try to make sure that on weekend you will get the class 11th mathematics lecture for free. Okay. So I think we have completed the equal functions and we have talked about what do you mean by term called domain and range, and we also discuss what are the functions. Okay, so the functions are nothing but a special type of relation, or you can say a mapping that maps an element from set A to set B, or you can say if you have element here x1 x2 dot 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 xn, and if you have a set B, if you don't know what are the sets, then you can refer to the previous videos of function. Okay, so the function is going to do what? Is going to take the value of this and is going to map the value from A to B. Okay, so that's the work of the function. It is nothing but a mapping. Okay, and there is a particular set of correspondence, or you can say the rule of corresponding. You can say that this image has to be unique, and you can also say that you can't have two images of same element. Okay, so it is called the image of image of x1. So here y1 is called image of x1 and it has to be unique. Okay, so we can say if we are going to have both the same image, like for example if we are having a comma b and a comma c. Okay, so what I'm saying that let us consider, no, let me write, if you are getting confused, let me write, if we have x1 comma y1 and we have x1 comma y2, then you have what? Y1 must be equal to y2. It says that your x1 can't be mapped to y1 and to y2. Okay, I think I made my point here clear. Okay, and this must be unique. Okay, so that's the definition of the function, and today we are going to talk about what are the real functions. Okay, real functions. Okay, if you want to know the detailed explaining of the function, please refer to my previous video. I have already started the concept of function from a basic thing. Okay, I also taken it as a juicer grinder example. Okay, you can look into that. So what do you mean by term called beta real functions? Okay, real functions are that if you know the function maps an element from set A to set B. Okay, if the elements of A, you can say x1 belongs to R, means real number. Okay, and the elements of B2, that Y also belongs to R, set of real numbers, then we are going to say that F is a real function. Okay, if only B is a subset of R, or you can say that all the elements in B only are the elements of the subsets of R, then we say that that function is a real valued function, as it is attaining real values only, and the value is going to be the elements in this. Okay, so I think I made my point here clear. Okay, so now we are moving further that what are the domain and range. As I have already told, if the function is going to map, like for example x1 x2 xn and y1 y2 yn, x1 to x, then x2 to, okay, let us consider that these elements here are not being mapped. Okay, so function is nothing but mapping. Okay, and the domain is going to be the set of all elements that is in A. Okay, so x1 comma x2 and so on, and range is going to be your elements y1 comma y2. Okay, only the elements that were being mapped by the function. Always remember this. Okay, and codomain is going to be the whole set B. Okay, I think I made my point here clear. Okay, so now moving on to the another topic, that what do you mean by term called how are you going to define the domain and range of a function? Okay, so what is going to be the domain of real function? Domain of real function. So let us consider we have a function fx is equals to 3x minus 2 x square minus 1. Okay, what does it mean? It means beta that if we are going to put 1 here, we are taking x is equals to 1, then we are going to get what? 3 into 1 minus 2 upon 1 square minus 1, which is going to be 0 not defined. Okay, I am giving you the example, like for example, if we are going to put x is equals to 2, then we are going to get what? 3 into 2 minus 2 upon 2 square minus 1, okay, which is a definite function. So that's what the function do. It takes out an elements of this set and start to map with this element, okay, and the rule of correspondence is going to be this, okay. But here we are going to define some criteria so that our function is going to be a well defined function, okay. So what is mean by that? We mean, like for example, what is the domain of the real function? We know that fx is equals to 3x minus 2 upon x square minus 1 is not going to be defined at x is equals to 1. I already told you, because at that time we get denominator is equals to 0, okay. So here the domain is going to be all the real values except x is equals to what? Minus 1. X is equals to, sorry, plus 1, okay. We can't put x is equals to plus 1, as at that time the function is going to be of the form anything by 0, and which is not defined, okay. So the domain of the real function is the set of all real values such that fx is well defined, okay. So I think I made my here point clear. So the domain is going to be, domain is going to be set of all real values minus first is your 1, okay. And if you are also going to put minus 1 here, see what will happen? 3x minus 1 whole square minus 1 is equals to by 0. Here it is also not defined. So real domain is equals to real number minus the set of values like 1 and minus 1. We can't put it in domain of this function. I think I made my here point clear. The domain of real function makes sense when the fx is going to be well defined, okay. If we are going to put x is equals to plus minus 1, then the fx is not going to be well defined, okay. So now same we are proceeding to range of real functions, okay. What are they? What do you mean by term called range of real functions, okay. So we know that we have a function fx is equals to, let us suppose, this y, okay. So range of real functions makes sense when your domain is well defined, okay. Domain is well defined. Like for example, if we have a function, like let us suppose we have a function fx is equals to x minus 2 upon 3 minus x, okay. So here we know that this function fx is going to be well defined if this denominator is not going to be equal to 0, and it is always going to be equal to 0 when your x is going to be equal to 3. So we can put any value of x except x is equals to 3. So the value, or you can say that this function is going to be well defined when your domain is equals to r minus 3, okay. And if we are going to find what the range of this function, then okay, just remember the converse process. If domain is going to be well defined when your range is well defined, and your range is going to be well defined if domain is well defined. Like for example, if we have to find the range, we are going to put as y is equals to x minus 2 upon 3 minus x, cross multiplying 3y minus xy is equals to x minus 2, okay. Send the x number of terms containing x this side. So 3y plus 2 is equals to x plus xy, take x common here, 1 plus y, 3y plus 2, okay. Send this term here, 3y plus 2 upon 1 plus y is equals to x. So if we have to find the range of this function, range of this real value function, it is always going to make sense when your domain is well defined. Okay, and domain is well defined only if and only if your y is not equal to -1. So we can clearly say here that the domain of fx is equals to set of all real values -3. Okay, it can't have -3 because at that the range is not going to be well defined, and the range of f, that is y, is going to be well defined at what is equals to r -1. Okay, I think I made my point here clear. Range of real function is well defined when your domain is well defined, and your domain is going to be well defined when your range is going to be well defined. Okay, so now moving on to the another types of functions. What are the various types of function we are going to discuss? Just remember that your logarithmic functions and your exponential functions. I'm extremely sorry for my poor handwriting. I can't do anything for that. My teachers were also fed up from this. But you can't make God to give you everything. Okay, He has to cut out some things. You can't have a good pedagogy skills. You can't be smart, and you can't have good handwriting. Okay, so I choose the two. I'm smart and I have a good pedagogy skills. Okay, so now moving on to the another topic, that we have a types of function. Okay, so first and foremost, I am going to make a separate video lecture on what are the logarithmic and exponential function, because they themselves demand at least 45 minutes. Okay, so I'm going to make a separate video on that. So the first function that we are going to discuss is your constant function. Constant function, as the name says, constant function is going to be a function that is going to give you constant value for any value you put. Okay, if we consider, if k is a fixed real number, then a function fx given by fx is equals to k for all x belongs to R is called constant function. And we are going to denote it by what? Fx is equals to k, where k is a what? It is a singleton set. Okay, and we can write fx is equals to y. So y is equals to something is going to be what? Y is equals to something is going to be a straight line. Y is equals to something is going to be a straight line. Tell me fastly what is going to be that? Parallel to x-axis depending upon the value of k. Okay, if we have what? X-axis here, y-axis here. If we have y is equals to positive of k, we are going to get a line parallel to the x-axis above. So here is what you denote the value of the entire function. Y is equals to fx is equals to k, and here it is what? Y is equals to fx is equals to minus k. If k is going to be 0, then we are going to get a line on the x-axis, or you can say coincident to x-axis. Okay, I think I made my point here clear. And k is nothing but your distance from origin. Y is equals to k. Okay, I think I made my here point clear. Okay, so now we have what? Next function we are going to get identity function. Remember, the graphs of the function are very important. Identity function. You know what are identity? You know what do you mean by term called identity? Okay, identity means I have my own identity. I can teach well in mathematics and science. Okay, so here we are going to get what? If we are going to map x by using any function, we are going to get the same x. Okay, for all x belongs to R. Like for example, what I am saying is that if we have a Cartesian system, if we have a Cartesian system, so you know that here you have what? 1, 2, 3, 1, 2, 3, -1, -2, -3, -1, -2, -3. Okay. So if you are going to put x here, we are going to get y. If you are going to put f1, we are going to get the same one. Okay. If we are going to put x is equals to 1, we are going to get y is equals to 1. Same thing like that. Okay. So if we are going to join this line, we are going to get a line passing through the origin, making 45 degree with the x-axis. I think I made my point here clear. Okay. So this line denotes the graph of the function, that is identity. Okay. Any doubt? I don't think there has been any doubt because they are very easy function. Okay. Then we have what? Your modulus function. Modulus function. One of the most important type of function is this. Okay. Remember, the graph of this function is very important. Okay. We have what? A function defined by fx is equals to mod x is equals to, means what? If we are going to take the value of x, then we are always going to get positive of x, mod x. Okay. And that value of x can be, you know, your x can be either negative or your x can be either positive. Hai. We are counting x is equals to 0 in this too, when x is less than 0. Any doubt? Okay. So here it is always going to give you the positive value of x no matter what the value you are going to put in x. Okay. Either you are going to put 0 or minus or something like that, it is always going to give you the positive value for that. It is also called a beta absolute value function. Okay. Any doubt? I don't think you are going to give any doubt for that. Okay. So now let us draw the graph for that. As we know, our y is always going to be positive. Hai. As we know that our y, that is this thing, denotes y is equals to positive of x, is always going to be a y. And for this, fx is equals to x is going to be same for x greater than or equal to 0. I already told you in identity function that no matter what you are going to put 1, you are always going to get 1 here. So 1, 2, 2, 3, 3. Okay. But now what for minus 1? Okay. If we are going to put minus 1, we are going to get 1. I told you, you are always going to get the positive value of x no matter what you put. Okay. And if you are going to put minus 2 here, you are going to get what? Not minus 2, you are going to get plus 2. Remember. Okay. So it is a line that is what? Making 45 degree with the this. Okay. So this is the graph of what? Your modulus function. It is a bit of very important function. Y is equals to minus x and y is equals to plus x. Okay. I think I made my point here clear. So now the next function we are going to deal with your what? Signum function. Okay. Signum function is very much same in that, but there has been a break. Let us discuss what is that. Signum function. Okay. Function defined by fx is equals to same mod x by x if the value of x you are not going to put as 0, and 0 if you are going to put x is as 0. So here we can break down this too. We know that if we are going to put x as minus, we are going to get minus x by x for x less than 0, and for plus x by x if we are going to put x greater than 0 and 0 at x is equals to 0. Okay. So it is your signum function. Cancel out, is equals to minus 1 is equals to plus 1 is equals to 0. Okay. So now plotting the graph of this. Okay. So here it is your x-axis and it is your y-axis. And you know that if we are going to put any negative values, we are going to get y as -1. Okay, so fx is equals to your what? -1. No matter what x you are going to do for less than 0, you are going to always get what? -1. So beta, y is equals to anything is a line parallel to x-axis and it is in what? Negative direction. So what? This line. Okay, remember this point is not included. As I already told you, it is going to be 0 at x is equals to 0. So that's why I didn't include this point here. So now if I am going to put, what? Positive values, I am going to get what? Y is equals to positive 1. Okay, if I am going to put any value of x greater than 0, we are going to get y as positive 1. So y is equals to positive of something, positive of k, it is a line parallel to what? X-axis. If you don't know the reason, let me explain you the reason why it is going to be parallel to x-axis. Because y is equals to k denotes the height, okay, or you can say the distance from this point, and it is always going to be constant when it is going to be parallel to what? X-axis. Okay, I think I made my point here clear. Now the next function that we are going to deal with is what? Greatest integer function. Very important function. Greatest integer function. What is this? It denotes, like for example, if we have any real number x, it is denoted by this symbol, and it means the greatest integer less than or equal to x. Sir, what do you mean by that? I didn't get it. Can you explain me? Yeah, I will explain you because that's my work. And see from the example here. Okay, I told you that the value you are going to put x here. Let me draw some points. 1, 2, 1, 2, minus 1, minus 2, sorry. 1, 2, minus 1, minus 2. Okay, so if I am going to put the value of x here, no matter what we are going to put, 0.1, 0.2, 0.3, okay, something like that, we are always going to get 0. Okay, remember, if I am going to put the value of x as from 0 to 1 including 0, I am always going to get fx is equals to greatest integer function as 0. Okay, and if I am going to put the value of x as 1, 1.5, anything in between but less than 2, I am always going to get what? Greatest integer as your 1. So it denotes nothing but your greatest integer less than or equal to that value. Like for example, if I am having 2.75, okay, so here this 75 is trying to reach 3, but it is not reaching that point. So I am going to do what? Just drop it. Okay, it is also called your floor function. If you are not going to get above, then please drop to your position. So here now it's going to do, now it's not going to do drop to 2. Okay, I think I made a point here clear. And if I'm going to put 3, then congratulations, you have reached the ceiling and the value of the greatest integer function is going to be 3. Okay, so I think I made my point here clear. You can continue the graph if you want to do. Okay, but the most important graph is of your negative one. Okay, remember. So now if I am going to put the value of x from -1 to 0, as you know, in minus thing, -1 is greater than your -2. Okay, so what's going to be the value for that? If I am going to put -1 to this, okay, we are going to get what? Greatest integer less than or equal to. So greatest integer less than -1 is always going to be your what? Can you tell me what is going to be that? Greatest integer, if I am going to put -1 to x, what is that? Your here -1. Okay, I think I made my point here clear. If I am going to put any value like 0.5, minus zero point 0.5, minus zero point 0.7, minus 0.6, something like that. So greatest integer less than this is always going to be -1, and here it denotes this thing. But at -1, it is always going to give you -1. Okay, so remember, the bulb are always be on your right hand side. It is one of the most important thing. Okay, here you can continue. Like for example, if I'm going to put the value of x as -2, I'm always going to get -2. But if I'm going to put value of as 1.5, minus 1.5, so the greatest integer less than is always what? -2. Okay, so I made my point here clear what I am trying to say. Okay, let's formulate this thing and write in example. So yeah, I told you, if I'm going to write x less than 0 and greater than -1, I'm always going to get at fx is equals to -1. Okay, and if I'm going to put x as -2 greater than 1, I'm always going to get greatest integer less than. Always remember less than. Okay, 1.5 minus 1.5, the integer less than minus 1.5 is always what? Your -2. It is not your plus -1. Remember, because +1 is your greatest integer greater than minus. Okay, minus sign have totally different meaning. There has been a lot of confusion. So fx is equals to -2. Okay, so it is what your greatest integer function, and we are going to continue some more function in other video. Don't forget to like, comment and subscribe to my YouTube channel. Okay, and if you want to inquire about live classes, then please contact me on 870-754-9139 or mail us on TANI. Oh my god, my handwriting, damn. Sorry, I can't do anything. I told you, I just picked two options. The god gave me three choice to take any two. Tanishq Trivedi edu@gmail.com. Okay, so thank you for that, and stay connected, stay updated. I'm also going to provide you some more videos in next lecture. Just revise through it. Thank you.